Dear students, now I am going to discuss about the preparation of alkyl halides. Preparation of alkyl halides. Preparation of alkyl halides. And in the last class, I discussed about the preparation of alkyl halides by group method. Now I am discuss about the preparation of alkyl halide by different methods. Say from alcohol, it reacts with PCl5 phosphorus pentachloride, then we get an alkyl halide. Phosphorus pentachloride, we get alkyl halide plus phosphorus oxychloride plus HCl. If we take another reagent from alcohol, if we take another reagent, say PCl3 phosphorus trichloride, then we get alkyl halide with the elimination of phosphorus acid H3PO3, it is called phosphorus acid. Another method by another reagent, by the use of another reagent, alkyl halide, when we react with thionyl chloride, we get alkyl halide. We get alkyl halide with sulfur dioxide, plus water. So it is called thionyl chloride. These are the different methods for preparation of alkyl halide by the use of different reagents. Say another methods of the preparation of alkyl halide, it is called Hans-Dicker method. It is called Hans-Dicker method. Hans-Dicker methods. Hans-Dicker method, what happened? Say we take silver salt of acid, silver salt of carboxylic acid. It is a silver propionate. It is from propanoic acid, so it is called silver propionate. When react with bromine or chlorine in presence of carbon tetrachloride, we get alkyl halide. If we take chlorine, we get silver chloride. If we take bromine, we get silver bromide. We get silver bromide. This method is called Hans-Dicker method. This is important. This is another method for preparation of alkyl halide. From alkyl, we also get alkyl halide. Because say methane, from methane we get chlorine, then we get methyl chloride. Similarly, if we take bromine, we immediately get methyl bromide. But halogenation of this reaction is carried out if we take iodine as alkyl halide. This reaction is carried out in presence of an oxidizing agent, say nitric acid or pyridic acid, because this reaction is irreversible. When we add alkyl halide, when we add iodine, then we form this reaction methyl iodide with the elimination of hydrogen iodide. But this reaction is carried out in presence of an oxidizing agent, because in this reaction it is an irreversible reaction so ultimately therefore methyl iodide percentage of methyl iodide will be decreased, because it is a reversible reaction. When we use pyridic acid or nitric acid as oxidizing agent, that what happened? That this is directly converted to this liberated hydrogen iodide. It reacts with the oxidizing agent, say pyridic acid. It reacts with liberated hydrogen iodide. It forms iodine with the elimination of water. So this iodine again reacts with the methane, so the reaction will be continuous and the production of the methyl iodide will be increased with the addition of oxidizing agents, say nitric acid or pyridic acid. That means this iodination of alkane takes place in presence of an oxidizing agent, because it is a reversible reaction. The production of methyl iodide will be decreased by the use of oxidizing agent. It again react with the liberated hydrogen iodide, it forms iodine, and this iodine again react with methane. Ultimately the reaction process will be continued. These are the different methods for preparation of alkyl halide. Then I am going to discuss about the properties of alkyl halide. So first I am going to discuss about the physical properties. Physical properties firstly I am going to discuss about the boiling point, melting point, etc. The boiling point of alkyl halides are more than that of corresponding alkanes. Say methane or methyl chloride. Methane and methyl chloride, the boiling point of methyl chloride is greater than that of methane because the carbon hydrogen bond is here. Because the carbon hydrogen bond is here, which is more polar. This carbon hydrogen bond is here in the alkyl halides, which is more polar, so more energy is required to break the bond. So the boiling point is more than that of corresponding alkane. Similarly, the boiling point of the compound, say isomeric alkyl halides, say will decrease. Say this is a compound, tertiary butyl chloride, and this compound is. This is a compound, and this compound, boiling point is decreased because the surface area decrease. Isomeric alkyl halide, these are the isomer with each other. This isomeric alkyl halide, the boiling point is decreased because the surface area is decreased, so van der Waals force decreased, less energy is required to break the bond. So isomeric alkyl halide, the boiling point is decreasing order. So this is about the physical properties. These properties is important. That actually mainly chemical properties is very important in chemistry. Chemical properties, alkyl halides shows three types of reaction. Firstly, it shows the nucleophilic. Substitution reaction. It shows shows three types of reaction. Nucleophilic substitution reaction. Number 2, elimination reaction. And number 3, reaction with metal. These are the three types of reaction with metals. These are the three reactions shown by the alkyl halide. Firstly, I am going to discuss about the nucleophilic substitution reactions. So, nucleophilic substitution reactions means those reactions which that's by the nucleophile. For example, this is an alkyl halide. This reaction when react with aqueous KOH means potassium hydroxide dissolved in water, then we get alcohol. This reaction is called nucleophilic substitution reaction because this is a substitution reaction because halogen is replaced by OH hydroxide ion and hydroxide ion. We all know that hydroxide ion behaves as nucleophile. So this substitution reaction is called nucleophilic substitution reaction with potassium bromide. Similarly, alkyl halide react with sodium alkoxide. This is sodium alkoxide, sodium methoxide. Again, it react, it forms diethyl ethyl. It is another example of nucleophilic substitution reactions of alkyl halide. This reaction is called Williamson ether synthesis. Because in this reaction ether is formed and this method is developed by Williamson, so it is called Williamson ether synthesis method. So another reactions of nucleophilic substitution reactions, say it react with potassium cyanide, so it react with alkyl cyanide. Cyanoethane with the elimination of potassium bromide. So when it react with alkyl halide react with silver cyanide, but in here we get nitroalkane. Cyanoalkane, isocyanate. Alkyl isocyanate is formed because in potassium cyanide, here potassium cyanide here, this reaction will occur in this way. Potassium cyanide is an ionic compound. So cyanide ion, bromide ion is involved, then it reacts with cyanide ion. Ultimately we get cyanoalkane with the elimination of potassium bromide. But in the second reaction, when we add silver cyanide we get isocyanate, because silver cyanide, it is an covalent compound. So when bromine is removed, this reaction will occur here like this. So ultimate we get isocyanate, alkyl isocyanate. In the first case, potassium cyanide is added, we get cyanide, but when silver cyanide is added, we get alkyl isocyanate, because isocyanate is a covalent compound. That reaction takes place in this way. This is another different examples of nucleophilic substitution reaction. Another importance of nucleophilic substitution reactions are aminolysis reaction. In aminolysis reaction, what happens when alkyl halide react with ammonia? I like this ammonia NH3. I like this NH2H. React with ammonia, we get primary amine. This is called amine. It is primary amine with the elimination of HBr. This primary amine again react with alkyl halide. Again react with alkyl halide. We get secondary amine. CH3NH. CH3, it is called secondary amine with the elimination of HBr. Similarly, when alkyl halide, this reaction occurs in fourth step. Secondary alkyl halide when react with another secondary amine react with another alkyl halide, we get tertiary amine with the elimination of HBr. And lastly, when the tertiary amine react with another alkyl halide, we get quaternary ammonium bromide. These reactions are called aminolysis reaction. This is quaternary ammonium halide. This reaction is called aminolysis reaction. This is an important reaction. So these are the different chemical reactions shown by alkyl halide. Another important reactions shown by alkyl halides are nitride formation reaction. If react with potassium nitrate, then you get alkyl nitride. Potassium nitrate, KON double bond, it is potassium nitrate. It is an ionic compound, potassium nitrate. When it reacts with this compound, then we get alkyl nitride. We get alkyl nitrate. But when this alkyl halide react with silver nitrate, then we get nitroalkane. Because nitroalkane, silver nitrate, it is a covalent compound. When halogen atom is reaction takes place in this way, then we get this is nitroalkane. Plus silver bromide. So these are the different important reactions from chemical reactions of alkyl halide. So in this alkyl halide, I have discussed about classification, preparation, properties, physical properties and chemical properties. This is about for alkyl. This is enough for alkyl halide.